नमस्कार दोस्तों, welcome back to our channel Shiva classes where researcher meets reality. Today we are diving into one of the fundamental experimental designs, that is CRD, completely randomized design. If you are preparing for exams like ICR, JRF, SRF, just or to strengthen your research or analytical parts, then this video is for you. CRD is the simplest type of experimental designs where treatment are assigned completely at randomized to experimental units. There is no blocking of groups or just pure randomization is there. Means our field is homogeneity. If our field is homogeneity, then we use this design. And this design is mostly used in lab or greenhouse. We use in polyhouse, we can use this design. For example, suppose we are testing an fertilizer or in horticulture we are testing GA3 treatment for 50 ppm or 100 ppm or 150 ppm. We are testing nitrogen or GA3 50, 100 or 150. Three treatments are there. Then if all plots are identical, then we use CRD design is preferred. If our plots are homogeneity, then we use RBD, which are discussed in previous class. You watch this lecture, we pin this lecture on comment and you watch there CRD, where we discuss the treatment, how we calculate DF value, how we calculate MS value, and how we calculate the error. This will discuss. So in CRD, we will discuss now what is the merit and what is the demerits of CRD. Merits. First we discuss the merits and then we discuss the demerits. Merits is the when our field is homogeneity, then we use CRD. If our replication is unequal, for example, we use 50 ppm, GA3 50 ppm, 100 ppm to 200 ppm, GA3 we use in ppm. If I want to replicate 50 ppm into 4 replication, 100 ppm into 3 replication, 200 ppm into 5 replication. If our replication is variation, if our replication got variation, then we use CRD. Means unequal replication, then we also use CRD. If our replication is equal, then also use CRD. But in CRD, we use in lab or greenhouse. Means our experimental field is homogeneity. If our experimental field is not homogeneity, heterogeneity, then we don't use CRD. This is the main point, key point. So in exams, ICR, JRF exams, the merits and demerits is also asked. So you focus on merits and demerits also. And second merits is, if our one replication is lost, suppose one replication in 50 ppm, one replication is lost. If 3 replication is left here 1 replication is left, here 2 replication is lost, 3 replication is left, then we also calculate the CRD design. If replication got lost, if error comes in replication, then we use CRD. But in RBD, we don't use. So two merits are there. If unequal replication and if loss of replication is there, then we use CRD. When we talk about demerits, when we talk, if in lab condition, when we suppose when the window are open, then sunlight comes into our petri plates, then our replication got damaged and it becomes heterogeneity, then we don't use CRD. So one replication is there, means it comes into unexpected things like sunlight or homogeneity comes. Simple, homogeneity comes. Then we don't use CRD. This is the merits and demerits of CRD means you write any error in lab, any error in lab, any real error in lab comes, then CRD is suppressed, then the value is suppressed. Then when we talk about ANOVA table, means when you calculate, when you any experimental design you kept in your field, then you make ANOVA, analysis of variance. ANOVA, analysis of variance. In analysis of variance in CRD, we discuss two things. First thing is difference between treatment. First is difference between treatment. And second things we discuss difference between within treatment. Suppose we kept GA3 50 ppm, 100 ppm and 200 ppm. These are our treatment. So we discuss the difference between this treatment first, treatment second. We discuss this treatment 2, treatment 3. What is the difference between these two treatments? And 50 to 200 ppm. First is difference between treatment, and second we discuss difference between within treatment. In this treatment, what is this difference between? So this is called error. So in ANOVA of CRD, we discuss two things. So we make the ANOVA tables. This is very simple designs which is used in lab conditions or polyhouse or greenhouse. This is very simple designs for horticulture, but mostly this is design is for horticulture, pathology departments. This design is used. Okay. Then we make ANOVA table. ANOVA tables. This is very important for exam points of view. Question are asked from these ANOVA tables. What is the treatments of CRD if our replication is 4 and treatment is 5? This type of question were asked. Then ANOVA table. First is source of variance. Second one is DF value. Third one is sum of a square. SS value you can write sum of a square. Fourth one is mean square. And fifth one is F calculated. In previous lecture we discussed how it is calculated, and now we also discuss. So those who did not watch the previous lecture, you should watch this lecture. So this design is understand very easily, because if you watch this lecture in sequence wise, then experimental design is very easy. In next class we will discuss the FCRD, FRBD, means factorial design we can discuss also. Okay. Source of design. First is treatment. Second is error, and third one is total. If our treatment is T, and number of replication is R. Number of replication is R. Then total treatment is RT minus 1. This is very useful. You can write this. Then we can calculate the error. Error is total minus treatment. Total is RT minus 1 minus T minus 1. We remove the bracket RT minus 1 minus T plus 1. Plus 1 minus 1 is cancel. RT minus T. And when we common the T, R minus 1. So then error is what comes? T into R minus 1. This is error. T into R minus 1. This is error. So we remember error is R into R minus 1. And treatment is, DF value of treatment is T minus 1. Total is RT minus 1. This one. Then we calculate the sum square of treatment, sum square of error, sum square of total, SS of total. Then mean value, we calculate the mean value, sum square divided by DF. Sum square of treatment, sum square of treatment divided by df. Df is t minus 1. Sum square of error divided by t r minus 1. This is mean square of error. Then mean square of total, we can also divide the sum square of total divided by df value. Then mean square calculated. When we calculate the f calculated is calculated as follow. Sum square of mean square of treatment divided by mean square of error. This is calculation of f calculated. If our f calculated is greater than f tabulated value, then our treatment is significant. If less than, then it's non-significant. This is about the ANOVA tables of CRD. Hope you understand the CRD, how to make the ANOVA tables, how to calculate the treatment errors and DF value of ANOVA tables. This question is asked in exam. For example, if any experiment, for example, we take NA 50 ppm, 60 ppm and 100 ppm. 3 treatments are there and replications are 4. 4 replications are there. Then in CRD, what is the error? What is the error in CRD? Then simple. 4 replication means treatment is 1 to 3. 3 treatment into 4 replication, 4 minus 1 means 9 error. How much error? 9 error. And when it's calculated, what is the total value of experiment treatment is total value of treatment is total value 4 into 3 minus 1 means 12 into 1 11. This is total value of treatment. The value of total treatment. So you calculate this and practice the more question. If you want more question, then subscribe our channel. We discuss the important topics of which are asked in ICR exams. Hope you will understand this. So we meet in next video. Goodbye. Radhe Radhe.